All right, so today we're looking at roots as fractional exponents. So what does that mean? That means if we see a square root or a cube root, we could actually write this expression as what we're taking the square root of raised to a fractional power. All right, so in this essence, a square root is actually just a number raised to the 1/2 power. A cube root is just the number raised to the 1/3 power. A fourth root would be the number raised to the 1/4 power. Fifth root to the 1/5 power. Sixth root to the 1/6 power, so on and so forth. However, mostly you all will just be working with, again, squares and cubes. So we're going to stick to our examples in the content of 1/2 and 1/3 when working with these fractional exponents. So this is just so that you know where they are when you see them. You don't freak out when you see a fraction as an exponent, because all it means is you take a certain root. But where does this come from? Like, how does this make sense? Well, what happens if you were to square a square root? So we know that the square root of 9 is 3, because 3 squared is 9, right? Okay. Well, if we think of this as just doing 3 squared and taking half of that, because 9 is the same as 3 squared, and we're really looking at 9 to the 1/2, well, this would just be 3 to the 2 over 2, because we're multiplying fractions, and 2 over 2 is the same as 1, and any number raised to the first power is just itself. So that stands to reason that this would be 3. Wow, that's pretty cool, pretty powerful. And that's what math is. That's what these numbers can do. They can do wonderful and powerful things. So my goal is so that you kind of understand that a little better. So if you see a 1/2, that just means take the square root of it. If you see a 1/3, that just means take the cube root of it. So let's see how that works with the cube root of 8, or 8 to the 1/3. Well, we would start off with 8 to the 1/3. You can change that to the cube root of 8 if you need to. Or you could think of, what number can I multiply times itself 3 times in order to get 8? Well, this would just be the same as doing 2 to the 3rd power, right? And if we take 2 to the 3rd and we take a third of those, this would really be 2 to the 3 times 1/3, which would really be 2 to the 3 over 3, which is really just 2, because that's just going to be 1. All right, so it's fairly simple to see that these fractional exponents are no different than just taking those roots, because when we do so, we see that we still end up with that whole number there. And we can see how it's just taking 1/3, like in this case with the cube root, it's taking 1/3 of the number that we have multiplying 3 times, which makes perfect sense. If 8 is 2 times 2 times 2, and I take a third of those, that would just be a 2, right? If 9 is just 3 times 3, and I just take half of those I have written down, I would just write down 3. Okay, so that's a pretty simple way to look at a square root and a cube root. Now, the other thing that I want to add to this is, what do you do if you have to take a root of a fraction? Well, you've already been taking roots of fractions this whole time. Let's take a look. Mr. Stevens, you have to stop with this, okay? Just because it's a whole number, you can't just keep saying it's a fraction. Well, it is. I hope by now that you realize that whole numbers are fractions. We can just write them over 1, and it's the same thing. So my argument is that you've been doing this already, because you've been asked to take the square root of 9 over 1 thousands of times. Your answer was 3, right? Well, let's see why that's true. How to actually take a square root and a cube root of a fraction, or any root for those of you that want to go further. So if we take the square root, we really want to take the square root of this entire thing. That means each part. Take care of the numerator and take care of the denominator separately. So this would be the square root of 9 over the square root of 1. What was the square root of 9? 3. What's the square root of 1? 1. Okay, good. So we have 3 divided by 1, which is just 3. And we're all done. Okay, that's exactly what we expect the square root of 9 to be, right? All right, what about the cube root? Same thing. We can just put it over 1. And so we're looking at the cube root of 8, and we're looking at the cube root of 1. So we will get 2 over 1, which should just give us 2. Okay, let's look at a real fraction, Mr. Stevens. These are real fractions, but I'll accommodate. I'll give you what you want. So let's look at what is the square root of 9/16. Okay, it's a good example. Well, based on what we said before, we would just take the square root of 9 divided by the square root of 16. Well, what's the square root of 9? Oh, that's right. That's 3. What's the square root of 16? Oh, that's right. That's 4. So the square root of 9/16 would just be 3/4. All right. I will see you soon. Remember that if you see something to the 1/2 power, that's the same as a square root. You see something to the 1/3 power, that is the exact same as a cube root. So actually, before I go, I'm going to throw something in. I think it's cool. So what if we had something written to the 2/3 power or to some other fraction? Well, we know what a third would mean. A third would mean to take what? To take the cube root. That's right. So this question is really asking, give me 2 of whatever the third part is multiplied together. So in other words, 8 to the 1/3 squared. And you know how to do that. This will give you 2 squared, because that's 2, and this is squared, and this will give you 2. If you want to be able to visualize this more, remember that 8 is the same as 2 times 2 times 2. So it will be 2/3 of these multiplying. 2 times 2, which will give you 4. All right. So just in case you see that in any equation that you're using for automotives or whatever, if you see a fractional exponent, remember that you should still take that as the root of it. And this just tells you how many of those to multiply. Still simple. All right. I love you, math. I love you guys. See you soon.